everyone. Today we're going to be talking about one of the other rules of random variables. We've been talking about doing a linear transformation for a single random variable, and now we're going to talk about if we wanted to combine two random variables together. So this is going to correspond with day 8 of your classwork. It's called combining two or more random variables. All right, so let's say I go back to our good friend Pete, and he has his Jeep tour business, and we already saw this distribution here for Pete in the past couple of weeks. And then separately, his sister Erin, it's also in the family that she runs another type of Jeep tour in another part of the country, and she has her own number of passengers who she brings every day and also her corresponding probabilities. Now, let's say the family wanted to get together and figure out what the sum would be for the total number of passengers that both Pete and Erin combine to take on any randomly selected day. Okay, so let's say their mom or dad or someone in the family was talking to them and said, like, oh man, so like between the two of you, how many passengers are you taking on your tours on any given day? So the first thing we could do is to create this sum, we could actually do this by hand, and that actually is going to be quite a lot of work. What we would have to do would be to consider all the possible sums of or combinations of sums of passengers between Pete and Erin. So if you think about what the lowest possible sum is going to be for Pete and Erin, it would be 2 plus 2, which would be 4. And then we can also have 2 plus 3, which is 5. 2 plus 4, which is 6, 2 plus 5, which is 7, and then that's just involving the 2 from Pete. And then you can also have 3 from Pete and 2 from Erin, 3 and 3, 3 and 4, 3 and 5, etc., all the way up to 6 and 5. Now, if I was writing this fully out, I could technically make a tree diagram or a probability distribution table for this. And let me do a quick, I'm not going to do the whole thing. I'm just going to show you the lowest combo to the highest. The lowest combo would be 2 plus 2. So it would be for Pete, this is going to be the Pete column, 2, 3, 4. You can go all the way up to 6. 2, 3, 4, 5, and 6. And then I would put in his probabilities, 0.15, 0.25, etc. And then for Erin, we would have, let's do it in blue. Erin's going to be in blue. We have 2, 3, 4, and 5. I'll put E for Erin here. And then her probabilities would be 0.3, 0.2, sorry, 0.3, 0.4, 0.2. I'll do them in black. 0.3, 0.4, 0.2, and 0.1, okay? All right, so I'm really not going to do this fully out, but I do want you to visualize that this would be a tree diagram that would have 5 times 4, which is actually 20 branches, because there's 5 combinations for Pete and there's 4 for Erin, and 5 times 4 is 20 total combinations. So picture that fully written out from 2 to 6, okay? And then we would make the sum column, and the sum would be Pete plus Erin, okay? So Pete 2, Erin 2, 2 plus 2 equals 4. We could have 2 plus 3, we said, which is 5. We could have 2 plus 4, 6, 2 plus 5, 7, 3 plus 2, 5, etc., all the way up to 6 plus 5, which is 11, okay? Now, to get the probabilities associated with these sums, I would multiply along the branch. So I would do 0.15 times 0.2 for the first one for the sum of 4. And I would get that value. And then I would go all the way to the last one, which is 6, which is 0.05, and 5, which is 0.1. 0.05 times 0.1, and I would get that probability here. Okay? Now, man, this seems like a lot of work, doesn't it? And if we did do this, we would list all of our sums, and then we would create a probability distribution for the sum of Pete plus Erin, and we would write our sums. Again, remember it goes from 4 to 11, so we put 4, 5, 6, all the way to 11. and then we would put the probabilities of the sums, okay? And man, this seems like a lot of work, doesn't it? It sure does. So my question is there a quicker way to do this? Because let's say I wanted to find the mean of the sum, the mean of this sum of P plus Aaron. How would I do that instead of fully finding every single combination of sum and then finding the mean of that? It just seems like a lot of work, doesn't it? So it turns out there's a quicker way instead of me doing it full out, which would be a pain in the butt, huh? So if you look ahead, we actually have a rule for this, and it's the rule for random variables. And what it says is if we have two separate random variables, x and y, in this case, Pete would be x and Aaron would be y, then we can find the sum, which could be Pete plus Aaron, or we could find the difference, Pete minus Aaron. And then instead of me doing all of those combinations that I showed you, combining every x plus y and finding their mean, which would take quite a lot of work, I could just separately find the mean of Pete, find the mean of Aaron, and then add them together. So that is what this rule is saying. It's saying instead of combining all the variables together individually, creating a lot of combinations, making a tree diagram, making your life a lot more challenging, you could just separately find the two separate means and then just add them together to find the sum or subtract them to find the difference. So at the bottom it says, in other words, the mean of the sum of two random variables is equal to sum of the means. Okay, so keeping that in mind then, we should be able to find the sum of Pete and Aaron. If you look down below, I know this says standard deviation, but I do just want to show you this. I know I kind of scrolled past this question, but just bear with me. So Pete's mean, if you did the mean, was 3.75. Aaron's mean was 3.10. So let's say I wanted to find the sum of Pete plus Aaron. Okay, Pete plus Aaron, it's going to be x plus y. Then what I could do is I can add these two means, 3.75 plus 3.10. So I'm going to do that here. Sorry, going back here. All right. So the mean of Pete, mean of x, equals 3.75. Mean of Aaron, mean of y, equals 3.10. So that says 3.10. Sorry, I don't have a stylus here at home. So to get the sum, I'm just going to do the mean of x plus the mean of y. 3.75 plus 3.1, and I will get the sum. Once I write the sum, I can write it as the mean of x plus y like this, showing that I could have individually added them and then found the mean one time, or I could write it as the mean of x plus the mean of y, showing that I added them individually and found them individually and then added them up. So this means on any given day, we can expect that Pete and Aaron can have a combination of about 6.85 passengers per day in total for their Jeep tours. Now, if you go back to this problem that I skipped over from before, we can now apply two of the rules that we talked about between today and the one that we did a couple of days ago with the rules of random variables with multiplying. So remember, P charges $150 per passenger, so we have to think about how much money he's charging per person. And Aaron charges $175 per passenger for their Jeep tours. Let C be the total amount of money that P collects, and E be the total amount of money that Aaron collects for any given day. From our earlier work, we know that the mean of C equals 562.5, and the mean of E equals 542.5. Find the sum of C plus E and find the mean. Okay, so the first thing I want to mention is that one of the prior rules that we went over was that we can multiply to find the product of 150 times the mean of P. So what we did to get the 562.5 was 150 times his old mean, which was 3.75, and that's where we got the 562.5. And that's one of the linear transformations that we talked about when we can multiply a constant by a mean. So similarly here, we're going to do Aaron 175 times her mean, which was 3.1. And we'll get what they're saying, which is of 542.5. Okay, so to find the sum, we just have to add the means together and we're done. So basically, the mean of the sum is equal to the sum of the means. All right, so just add these together and you'll get the answer and then interpret. Okay, so I added them and I got 1105, and then I wrote if we took many, many days, like in the long run, remember, if we did this many, many times, we can expect that Pete and Aaron combined will collect about $1,105. So notice I'm using the word expect, and I'm talking about in the long run, what I think is going to happen to their combined sum. Okay, now let's go back to standard deviation. Do we think that we can add standard deviations in the same way that we can add means? So remember, when I showed you that exciting tree diagram, I combined everything up, and then I talked about how I can find a combined mean, or I can individually find the means, and then I can just add them together. So think about now what the definition of standard deviation is. Do you think that I'm going to be able to find the standard deviation of Pete, separately find the standard deviation of Aaron, and then add them together? So think about what the definition again of standard deviation means. Standard deviation is the average deviation from the mean. So on average, how much does any chosen X value deviate from the mean? Okay. So think about that we found the average deviation of the number of passengers for Pete from his mean and the number of passengers of Erin from her mean. If we combine them together, would the standard deviations be the same if we found the combined mean? Would those deviations be the same? And I'm hoping you're going to say no, because when we combine together and get a new mean, that distance from that new mean is not going to be the same as individually finding the standard deviation of each one of these guys. So we cannot actually find the standard deviations and add them together. It also has to do with the fact that standard deviation, we can have, it takes into account that there are numbers that are above the mean and there are numbers below the mean. So for example, a number like 5 and 6, those numbers are above the mean. And then there are numbers below the mean, like 2 and 3 are below the mean. So there's going to be positive differences from the mean and negative differences from the mean. And basically, when you're finding the standard deviation, all those distances get squared. So the negatives kind of play a role as well in all this. So basically, we cannot add standard deviations, okay? So what can we do instead? The first thing to note is we're not allowed to apply the next rule unless the two variables are independent of each other. Okay, now independent means knowing that one thing has happened will not help us to predict the other. So it is reasonable to assume that if we know something about Pete's Jeep trip, it won't actually affect Aaron's, we hope. Okay, maybe they don't have the same weather in the two parts of the island. So it turns out, what can we do? We cannot actually add the standard deviations, which I'm going to underline here, 1.0897 and 0.953, 0.943. If we added them together, we are not going to get 1.441. And you can easily see that even if you do this in your head. 1.0897 plus 0.953 is not going to be 1.447. So we can't work with standard deviations. But what you can see is that they have, what's up here is the standard deviation squared. And that is actually called the variance. And it turns out we can work with the variances. So this is the variance of Pete. This is the variance of Aaron. To get the variance, you just take the standard deviation and you square it. And then you are allowed to add up the variances together. And you're going to get the combined variance, which is down here. And then you're going to see you're going to square root that number, and that's how you get the standard deviation. So basically what it has to do with is kind of think about the Pythagorean theorem. It's like a squared plus b squared equals c squared. In this case, this is x squared plus y squared equals sum squared. You take your standard deviation of x and you square it, basically to get rid of the negatives. You take the standard deviation and you square it to get the y. You add them together to get the combined variance, and then you square root it. Okay, so I just labeled this here, which I highlighted, I underlined or circled already. This is the variance of Pete. This is the variance of Aaron. To get those, you just take the standard deviation, you square them, and then you can add those together to get the variance of the sum. So going down below, you're going to see this is the rule. And again, it shows variance, not standard deviation. So that's why you have the squared happening here. So the variance of the sum is equal to the variance of x plus the variance of y. And then when you want to take the square, when you want to find the standard deviation, you just take the square root. So it does kind of look like a squared plus b squared equals c squared, or even the distance formula if you think about it. Because remember, the Pythagorean theorem is a squared plus b squared equals c squared. And then let's say you wanted to solve for c, you would take the square root of that, right? There you go. So just remember that you cannot apply the rule above unless the two variables are independent of each other. Now, what about the difference? This is where, again, it gets a little more interesting and harder maybe to understand conceptually. The difference is x minus y. So let's say we wanted to find the difference between Pete and R to see basically who's doing better. Let D be the difference, which is x minus y. So that's going to be Pete minus Aaron. So similarly, remember how I worked out that tree diagram for the sum where I did 2 plus 2, 2 plus 3, 2 plus 4, 6 plus 5, etc. And I had shown that probability distribution table. This is the difference table. So instead of doing 2 plus 2 here, they're doing 2 minus 2, which is 0. 2 minus 3, which is negative 1. 2 minus 4, which is negative 2. And 2 minus 5, which is negative 3. So the lowest difference you can obtain is negative 3. And the highest difference you can obtain would be 6 minus 2, which is 4. So again, all these probabilities came from basically someone making a tree diagram and multiplying all the individual branches together and then adding them all up. Okay, so now let's revisit. Remember, we could not add standard deviations. So do you think we're going to be able to subtract standard deviations? I'm hoping you're going to say no here. So look at the standard deviation of Pete, look at the standard deviation of Aaron, and look at the standard deviation of the difference. Clearly, these were not subtracted, right? 1.0897 minus 0.943 is not 1.441, okay? Cannot be subtracted. But let's look at the variances and see if we could have worked with those. Here's the variance of Pete, here's the variance of Aaron, and here's the variance of the difference. So were these subtracted? I'm hoping you're also going to say no, they were not. And again, here's the situation. The difference, basically, even though it's a minus sign, when you are squaring everything, the negatives get squared and become positive, and the differences actually get further apart, even though you think that when you're subtracting, things might get closer together. So it turns out that when you find the standard deviation of this distribution, the difference distribution, that the variances actually add. And that is one of the hardest rules to memorize or understand. So it says, even if we have a difference, which I'm going to circle here, difference means subtract, even if you see that these x and y are being subtracted, the variances add. And that means they are never going to subtract. Variances never subtract. And we never work with standard deviation ever. If we want to get the standard deviation, we take the square root of the variance. Okay, so there you go. That's the rule here. I'm going to circle it, star it. And now you basically know all your rules that you need in order to proceed. So here's an example. I'm going to kind of organize it for us, and I would like us to do this in the future. Put the variables separately. So put Pete, put Aaron, and then put sum or difference, okay? So Pete, we said, is C for cost collected by Pete. E is Aaron for cost collected by Aaron. D is going to be the difference between Pete and Aaron, and that's defined as C minus E in that order. So it's saying earlier we found that we could multiply 150 by the standard deviations and get these standard deviations, okay, for cost. And we did that a couple of days ago. So the standard deviation of Pete was 163.46. The standard deviation of Aaron was 165.03. So let's say I want to find the standard deviation of the difference. To do that, we just have to find the variances first. So square individually the standard deviation. So you're going to do 163.46 squared and then 165.03 squared. And then what you're going to do to find the combined variance of D is you're going to add the variances. Even though it says subtract, you're not. You're going to add them. So you're going to do the variance of x, or Pete, plus the variance of E for Aaron, okay? So you're going to do 163.46 squared plus 165.03 squared, okay? Do that, and then whatever you get is going to be the combined variance, and then at the end, that's going to be the variance, so that's sigma squared of this difference, sorry, D for difference, and then at the end, you're going to square root that to get the standard deviation. So do that. Okay, so when I did the variances, I ended up getting 53,954.07, and then when I did the square root of that, I got the standard deviation to be 232.28. So if I wanted to interpret it, I would say if we had many, many days of many, many tours, on average, the difference between Pete and Aaron's total cost collected would be deviating from their mean difference by 232.28. Okay, lastly, I want to challenge you to try this example, okay? So here's what I want you to do to set it up. It's talking about random variable R and random variable S. So whenever you're doing a question, I really would like it if you set it up like this. R, S, and then the difference or the sum. So R minus S. I guess we're doing the difference here, okay? And then what I want you to do is, if it says the shape, center, spread, list them. In this case, it doesn't say shape. It just says the mean of R, which is center, and the standard deviation of R. So 10 and 4. S, it's telling you the mean of S is 7, and the standard deviation of S is 3. Okay, that's here and here. The mean of R was 10 and standard deviation 4. And now we want to do R minus S. So I want you to go back to your rules and try to do the mean of R minus S. Ask yourself, can you subtract means? So do that first. And then can you do the standard deviation? Okay, do it and get your answer. So first, I'm hoping that you said you could indeed subtract the means. So 10 minus 7, the mean of R minus the mean of S equals 3. So already, if you knew that, we're down to A, B, or C. But now I'm also hoping that you realize you can't work with these standard deviations. So what you have to do is first square these to get the variances. So 4 squared is 16. That's going to be the variance of R. The variance of S is going to be 3 squared, which is 9. And then, even though it says difference, we're actually going to add the two variances together. So we're going to do the variance of R plus the variance of S. And remember, it's because that difference, the negative gets squared and it becomes positive, and actually the difference gets further apart from the mean, the combined mean. So we're going to do 16 plus 9, and then we're going to do the square root of that. So we get 25, which is going to be the variance of R minus S, and then we're going to take the square root of that, and we're going to get our standard deviation, which is 5. So our final answer is choice B. If you picked it, great job.